And I find some statistics extremely powerful. So even though this is irrelevant bad news, I gotta tell you. California teens are found at fault in 2/3 of all fatal collisions that involve a teenager. In other words, if there's a fatal accident that involves a teenager, it's twice as likely it was the teenager's fault than the adult's fault. For the ages 15 to 20, vehicle collisions are the leading cause of death, more than any other preventable or natural cause of death. Teenagers are twice as likely to be in an accident, but they drive half as many miles as an adult. So per mile, you've got quadruple the chances of being in an accident. If you're under 18 years of age, your risk of dying in a car accident are 2.5 times that of the average driver. And they are 3 times higher than the average driver being injured. The worst irony is, you're inherently better drivers. You have better muscle control, faster reflexes, better eyesight, better muscle control. Did I already say muscle control? Mm-hmm. The problem is, you have all of this amazing teenager abilities, and instead of using them for good, you use them for evil. All of your attention is devoted to playing with your sexy parts or cell phone or something, instead of driving.
I do.
Teenagers are like, oh, this driving is so easy, I am a superpower, and you are. So whatever, oh my god, she was on, and I was like, an actor, run over some old lady. I find it really sad that our best drivers have the worst driving records and are most likely to kill the rest of us. When we grown-ups drive, we're freaked out. We are panicked. When I drive, I'm like this.
Why is it
That ever problem?
just in California that we don't know?
Well, California drivers tend to have bigger cars, and so that increases your liability. And California is kind of a higher income area, so more teenagers tend to have cars. And also, California has some of the most commuting, because we're such a sprawling urban area. So it's a perceived or real need for cars is higher in California. But those are just things I'm guessing about. I don't know if there's other factors. California definitely has a pretty hot car culture. And we're not number 1 for teenage mortality for cars. We're number 2. There's some other state, I don't know which, that's even worse. I don't know which. All right.
New York.
Anyway, I just thought I would share those statistics because in a momentary checking of emails right before I started school today, I saw that and it really struck me. I fear for my life when I'm on the roads because I know all of you. What's that?
That's why you shared it?
Yes. Please don't kill me or my children. Please. Eyes on the road. Hands on the wheel.
Get it too. Eyes on the wheel, hands on the road.
Okay. Some reminders about the stars. Oh, no, let's do the warm-up. Because this is one of the last questions in the study guide, and it gets stars anyway. So pros and cons of nuclear power is an interesting question. Let's do the pros first. I'm waiting. Pros?
Efficient.
Yes, thank you for raising your hand. It's extremely clean. It's probably the least carbon per kilowatt. Don't forget that there are still carbon emissions because you have to get the uranium. Power plants use a little electricity. But the lowest carbon pretty much across the board of any energy system. What else? Near zero carbon. Yes?
Efficient.
Uranium available?
Yeah, we have a fairly decent uranium supply. of the uranium we can get easily, we could do all of humanity's electricity supply for like 70 odd years. And if we get better at taking it out of the ground, we could go 300 or 400 years. Yeah?
Efficient.
Well, this is an interesting question. How do you mean efficient?
Like, you don't, I guess, with the amount of, like, stuff you're putting in, you get a lot of energy out. Like, you're just putting in basically water and getting steam energy out.
Yeah, I mean, per unit of kilowatt energy, you get a lot of energy out. But there is a sense in which it's not efficient, and we'll talk about this when we get to cost. So remember that thought. Anybody know any other benefits?
Provides jobs.
Actually, a very small amount. It has some of the least labor of any energy source. Do you always wear X's, or do you go to a show?
I went to a show.
Back in high school, some of us wore X's as if we'd been to shows. We were crucified in the X. Nobody yet has mentioned the safety thing. Nuclear power plants are extremely safe if you rule out human error. Of course, that's a touchy subject, right? Because humans make errors. You know, juggling chainsaws on a tight wire is perfectly safe unless you have human error. And like juggling chainsaws on a tightrope, there's a lot of ways to make errors, and those are very serious when they happen. Oh, yeah, we already talked about that one. Blake?
Are we still talking about pros or?
Yeah, there's one more I'm looking for.
Okay, other cons. Come back.
The last pro that nobody mentioned either is that it is the cheapest operational energy source. So per kilowatt hour, once the power plant is running, it is the cheapest. But this is the funny part. I always leave this one for last. It's a great transition to the cons. Pro, it's the cheapest operationally. Con, it's the most expensive when you go from building it, operating it, and shutting it down. You see, once it's up and running, it is by far the cheapest. Very little labor, very little material, very little inputs of energy. So once you've got it running, the operational cost is very close to zero. They operate for less money than solar panels and wind turbines per kilowatt hour. But the full life cycle is very expensive. Building them is really expensive because they're so fancy and complicated. And there's a giant cost nobody has paid yet, the waste disposal. Nobody knows how much that costs because it lasts longer than we've been doing anything. Yeah?
Well, I was just saying it takes like 8 years to get the plan approved. Is there a lot of money involved in that, in the whole approval process?
Permitting and
as well?
stuff?
Yeah. Is it more just like...
Probably more expensive than other power plants, I would imagine. There's probably more details, more engineering and stuff, yeah. I would imagine it's more expensive to do the paperwork.
Does it all completely overrule the efficiency?
Well, the payoff point for nuclear is one of the longest. So coal pays for itself in something like 3 to 7 years, nuclear in 30 to 70 years, because it's just so expensive to build it. Even though it's really profitable to run it, it's just so much money in the ground before you turn it on. Audrey?
Oh,
That was a question. Of course, however rare the accidents with nuclear power are really, really, really scary. So that's an obvious con that you could wipe out all humanity, I suppose. Yeah?
Couldn't like terrorists target nuclear power plants?
That's an excellent point. They could probably target a lot of other power plants too. But yeah, the nuclear risk thing is a very scary national security question. Yeah. Yeah. And there's something that I personally consider a con that I find very difficult to explain in terms of curriculum. So I don't know how you're going to want to write this down, but you should consider one other question. When it comes to nuclear power, I have a fear of commitment. You know how, like, if a man or a woman is famous for cheating, and they promise, I'll never cheat on you, baby. You're like, kinda, I'm skeptical. You know what I'm saying? Fear of commitment? The funny thing about nuclear power is, I don't trust that anybody can keep me safe from nuclear waste because it's a really long promise. You guys know what's the oldest government on Earth?
The Catholic Church.
400 years, maybe?
No, in Europe it's maybe a little bit longer.
Operating the same way, House of Commons, House of Lords, 500 years?
Well, operating the
There's
same
some
way.
elementary schools in Europe that are over 400 years old.
I don't think we're 4 to 500 in England.
I don't know about in England, but somewhere in the UK or in Europe.
Yeah, okay. So Catholic Church, what, 450, 500 years? Yeah, 600 years maybe? Let me keep throwing out some numbers, because this is an interesting question. Look, the oldest governing document, I believe, is the Constitution, right? 240 years?
The Magna Carta.
That's still, yeah, but it's still operational.
Yeah, it's an operational governing body, or governing document.
The Bible.
Yeah, I guess, like, seriously, we could call it like a fundamentalist religious text if you want. Maybe 2,000 years, maybe. Questionable. What's the oldest language? Maybe some random, like...
Arabic.
Yeah, Aztec. What is that, 10,000 years? 6,000 years?
Do people still speak Aztec?
What's the oldest...
Latin, maybe. Latin and Greek.
Was it Latin before Greek?
Yeah, Latin's older than Greek.
Yeah, Latin's older than Greek, and that's only a couple thousand. But look, I'm trying to make a point so we don't need to quibble with the details. The oldest building I can think of that still stands, they just found a new pyramid right next to Giza, 4,600.
They just found a new pyramid.
Yeah, they just found a new one. Whoa! The one thing that blows Graham's mind in my apes class is they just found a new pyramid.
How do you not see a pyramid?
Because it's small and it was abandoned. Who cares? Look, I'm trying to make a point. If you call the oldest language 10,000 years old or something, how can anybody make me a promise that they can manage nuclear waste which lasts 600,000 years? Like, that promise just carries no weight.
Promise or weekend.
It's like people are like, yeah, I promise we can manage nuclear waste in the United States. We'll make the responsibility of the federal government. Trust us. And I'm like, no. Because in 3,000 years, when this is some other country, you can't promise what they're going to do with it, and that's going to be just as radioactive. Maybe more. This is what I mean about my fear of commitment with nuclear power. The timeline is outside the scope of credible promises. If I promise my wife I'll do the dishes for 100,000 years, she's not going to negotiate based on that, because she knows I'm not going to be here in 100,000 years. And so when someone says, don't worry, we'll keep humanity safe from environmental hazard of radioactive material, I'm like, no, you cannot make that promise. You just made a problem that you will not be here to solve. That's my problem with nuclear power. First Graham.
It also connects to it. Only the last, like a power plant is only can be around for 50 years, right? And then they have to
Ish,
get rid of
70
it.
maybe, yeah.
So, yeah, and also like it's a much less important fact, but it's also not like attractive just aesthetically.
Yeah, I guess. But it is a small power plant, so per kilowatt it's at least 2 complaints. Yeah.
How many thousands of years also to take care of the waste, the nuclear waste?
That's what I'm talking about, and I don't know. Hundreds of thousands, potentially millions for some of them. I mean, The really high level stuff can't stay hot for very long. So the most high level, the most volatile is probably 2,000 to 6,000 years, and that's the stuff that's like super gnarly. Then like really gnarly, tens of thousands, and pretty gnarly, hundreds of thousands, and you know, you don't want it in your cereal millions of years.
Well, the timeline's still extending, right? 'Cause it-
Right, right, 'cause we're still making more.
Exactly.
So it's from today, for the stuff we just made today. I hate to add my personal bias to the nuclear power question, but conceptually I encourage you to think about that. It's like a mathematical impossibility in the conversation about nuclear safety. Like, I don't want people to blame me after I've died either. Like, even if I promise to be a nice guy as long as I'm alive, I don't want to kill people after I've died either. I don't know if that makes sense. That's not necessarily practical. It might just be karmic, and maybe I'm just getting into belief systems now. But that just doesn't sound right. To me. Personal thing, I guess. Anybody want to talk more nuclear? Yeah?
When you say 1 pound of uranium is 3,000 pounds of coal in terms of energy, is that
3 million.
Or yeah, 3 million. Is that 1 pound of 235 or 1 pound of 3% of 235?
That's a great question. I think that's 1 pound of 235. Yeah, because it's the energy released in the 236 explosion. Yeah.
Do you perhaps know how much, like, the equivalent, like, what 1 pound of uranium would look like if it weighs so much?
I don't know. It's extremely dense, so it would be smaller than a pound of lead.
Yeah.
And a pound of lead is about that size. Gabriele after class, athletics office. Alright, so let's do the stars. I gotta warn you, the exam tomorrow is based on vocabulary throughout the unit. There are no tricky big words in English, but there are many tricky energy unit words. Don't say I didn't warn you about that.
Like also this packet or separately?
I believe it all appears in the packet somewhere. By law, I don't put anything on the test that wasn't at least asked in the packet. Remember, some of the stuff in the packet we answer in class, but if you can answer all those questions and you know all those words, you have 100%. So here we go with the stars. I'm going to go in the order of the study guide. In the vocab, 1 star, first law of thermodynamics, 1 for second law of thermodynamics, 1 for electrical resistivity, one for energy efficiency, 1 for cogeneration. Start to play. 1 for acid mine drainage, 1 for fractional distillation, 1 for depositional basin, 1 for peat. In the 19 vocab, 1 for digestion. In the 20 vocab, 1 for fission, enrichment, moderation, and please note, moderation is what you do with the moderator. Neutron control to regulate the reaction rates, moderation.
Wait, what? Oh, neutron control.
Chain reaction gets a star. In the study goal, 1 gets a star, 2, 4, and 6. Study goal number 10. Gets 3 stars. But just so you know, you're not going to see that as a question. Those concepts will be required for many questions. So number 10 is conceptually critical, not vocab critical. $11 gets 3 stars. $13 gets 2 stars. And in number 13, there's something really important I have to remind you about. Because we waste half of the energy we use in this country, remember that if you can cut your consumption by 1 unit, our nation can save 2 units of supply. And likewise, 2 units of environmental harm. For electricity, the ratio is 1 to 3. Because you lose a third in generation and half of the remainder in transmission. So remember that thing about why savings is so much more important than more supply. $14 gets 1 star. $19 had many parts. Each part gets 1 star. $20 gets a star, especially for fracking, which a lot of my students don't realize is mostly for natural gas, very little for petroleum. Also remember that, except for South Dakota, I guess South Dakota right now is doing a bunch of fracking for petroleum. Something weird about their geology. Remember also that fracking is what we call tertiary extraction, because you inject other liquids and chemicals, and it takes a lot of energy.
Can you spell that?
What?
Tertiary.
Tertiary, T-E-R-T-I-A-R-Y. Tertiary. $23 gets 2 stars. 25 gets a star. 26 gets 2. 27 gets a star. 29 gets 2. And don't forget we added solar thermal. 32 gets a star. 34 gets a star. 36 gets 3 stars. And I'm sorry, I have to add a vocab term this late in the game. In number 36, please add the word fallout. Does anyone know what fallout means? Nick?
Isn't it when the radioactive particles after explosion react?
Radius, right?
It's like a a dusting of fog or sand or ashes. They are particulates that carry radioisotopes.
And the fallout zone is like the area in which that.
Yeah, the fallout zone is the space where dust settles.
Okay, alright.
Number 41 gets a star for waste storage. 42 gets a star. The conversation we had today about pros and cons. And now we have about 14 minutes to discuss the reading packet. I'll do the stars as we go through it. Okay, number 43 and 44 are both cool local topics. For those of you that plan to spend a lot of time in Santa Barbara, this is just how to get more local, but that's all. Uh, 45 gets a couple of stars, especially the table on the back, on the third page. It looks like this. And there's something that we haven't really talked about too much. You know, it might come up in questions, but I'd like to mention something now. Please do remember that America's power grid is 100% on demand. There's no storage anywhere on the grid. Our entire energy calculus would be totally different if we could store renewable electricity. It would change our economy, our global competitiveness, our industrial capacity. If you want to change the world, focus on how to store renewable energy without spending a ton of money. Probably the number one crux question in environmental science today is how do we store renewable electricity? Because if we can store it, the price of renewables becomes super competitive. We stop global warming. By addressing global warming, we address long-term water supply, long-term food supply, global ocean health. The single biggest game changer in environmental science would be storable electricity. There's ways to store it, it's just too expensive or too inefficient to be worth the expense. So if somebody has that perfect market-ready energy storage, it changes everything. Number 46 gets 1 star. 47 gets 2 for this part of the article. The part with the big number 9. '48 and 49 are interesting articles, but honestly, I can't imagine that they're going to be a big deal.
in environmental science for the long run? Number 50 gets a star. It's part of the conversation that we just had about nuclear power. That goes with 42 very well. '51 gets a couple of stars, but especially this part. The table that compares all the biofuels. Number 52 gets 3 stars. It's important that you know megawatt means to cut down electricity consumption. Megawatt is to lower demand. I'm not sure that's numbered in your packet, but if you look at the study guide, it says 52 is something or other about megawatt power. You see, I've been talking all this entire unit about how we got to cut demand, cut demand, cut demand. Not more supply, less demand. 52 is an excellent conversation about that. So I highly recommend that article. And finally, I told you yesterday, but the last page of the reading packet, that comparison of doses of radioactivity, I think that's a really useful tool for understanding radioactive exposure. Are there any questions in unit number 7? We got about 6 minutes. It's the hardest test of the year. How can I help you, Blake?
Already talked about it, but I didn't really get down to the depositional basin, fractional basin.
Depositional basin was those places where heat washes up, where organic material settles underwater. That's where you use heat to separate the different size carbon chains based on their evaporation point. Remember how more heat will evaporate bigger carbon chains? So if you're careful about the temperature, you're only going to get one thing coming out in the gas. Yes?
It says ask me about
Vitrification. Did we not talk about this? This is a very important question in nuclear waste. What number is that? 40? Look at number 41. Vitrification is to encase radioactive waste in glass.
Have you seen uranium glass? Have you seen uranium glass before? It's like the glass that like glows in your dark under like UV lights and stuff. You used to make like
It's really hard to put it in this.
Let me explain. Has anybody ever seen those ice cubes that have like mint in them?
Yeah.
Or like popsicles with a worm in them? The idea is you make a big glob of glass with your high-level radioactive waste in the middle. The point is that it keeps it very well contained. One of the scariest things about radioactive waste is that the barrels leak. Or that the containers will rust. But really thick glass is really sturdy. People have said you can dump those into a deep sea trench or something. And that radioactivity might travel a little bit, but it's not going to leak out. So at least you're not going to have like localized poisoning with the material. So you put it someplace far away from your food supply and far away from the people, and it's pretty, you stack them in a big pile of ice cubes in the desert. And because they're made of glass, they pretty much last like many thousands of years. So the longest storage option that you can do right now and then have it last a very long time is to make them into a huge jello mold, like a big lump of glass with the radioactive waste in the middle. Yeah.
Like you said, how radioactive waste continues to decay and it's really hot, how does the glass just not melt?
I guess it's probably below the melting point of the glass, but
Okay.
there may be some things you can't put in there. I don't know. It's a good question. Yeah.
Is the definition for chain reaction just like the concept of, and then also passive safety?
Passive safety is when a reactor has a safety mechanism that doesn't require a human. So like if the reactor melts down, it falls into a pool of water with boron in it.
Okay. Thanks.
So you don't need a human to do the safety. It's like a built-in backup. After the worst case scenario, there's another way to make it safe.
Okay.
Again, that's fission, right?
Fission is splitting an atom.
Fusion and pebble bed reactors.
Fusion is to get energy out of making an atom. And technically, you get a lot more efficiency with making atoms than you do with splitting atoms. But it's not commercially viable yet.
The sun is an example of fusion, right?
I think so, but I'm not an expert.
And then pebble bed reactors.
Pebble bed reactors, instead of having fuel rods with all those tightly packed pellets, each little pebble is wrapped in ceramic so that instead of needing water for a coolant, they can survive being dry. Airflow is enough to take away the heat.
Like the place in Germany.
Because the ratio of volume to surface area is higher, so it can dissipate the heat well enough.
It's a lot more expensive to do that.
Is that what they use, like ceramic brakes, so they don't overheat?
I don't know.
There's
I guess so, yeah.
Natural gas combined cycle power plant.
Natural gas is delivered under pressure, so you use the gas pressure to spin a turbine, but then you light the gas on fire to spin the turbine.
And that was called what again? Natural gas combined cycle power plant.
What else? Yeah.
So with that diagram you have right there, how you said it was really important for the AP test, but like doing every single part for this test, because we have
Probably.
Okay.
I try not to give you stuff that you don't have to know. You can get away with not knowing parts of it on one exam or another, but basically, I deliver to you all the content that I think is relevant. Which part I'll ask you about is a different question. I will not ask you every word there on the test tomorrow, no. But all those words are just as likely to be on the test, because I think all of those are just as likely to be on the AP test.
The first law and second law, the first is the amount and second is quality. Is
Uh-huh.
that the easiest way to remember it, or how else?
For me, that's the easiest way. I hope it works for you. Yeah,
Are we going to need to try that on the test tomorrow?
very possible. Yeah.
For andesite, all those, I just said that they were types of coals. Is that enough information, or do I need to say like?
There was the drawing we made in number 25 that had the energy supply and the moisture. That's a better way to organize them.
Okay. And then peat's just the stuff that lays on top of the ground.
Decomposed plant stems?
That stuff. What else, children? I want to be helpful. I'm glad so many of you aren't worried. Well, good?